Saturday. Yeah. Saturday, and the stream is titled something different today. Well, it's titled the same as the last stream, but with the word debug added. Go on, where's the stream? Where are you? It says I've gone live, but it doesn't show up on YouTube. Yes, we're live. Good. There we are. Magic. Sounds working. And where did we leave off? Oh, wait a minute. Let's say hello. There we go. Make sure we've got timestamps. Okay, let's try it here. There we go. We've got timestamps. Oh, fantastic. Right, I'm happy. Are you happy? It's Saturday. We should all be happy. It's a day off, except for me. At the end of last stream... Oh, by the way, you've got the code for the start of this stream. At the end of the last stream, I'll just check that. We left ourselves in a peculiar situation of... does the program work or not? Well, actually, yes, it's working. I have 100% confidence in the code that I wrote. It is written, to the best of my knowledge, correctly. I haven't checked it. I've done nothing. I went and played games yesterday. Nobody was interested, nobody watched, so I'm not even going to tell you what I played yesterday on Twitch. Instead of working out this, I went and played a game on Twitch instead. But today, I've added the word debug. Yes, because today we're going to have a lazy day. It's Saturday. I've earned a break. We're just going to debug this. It's got 00, so you've got the code as well. It's up on GitHub. If you're following the series, you know where it is by now. And if you're not, ask in the comments below. It's on my GitHub at Amberskies / then it's going to be Amberskies_QT, I think, for this one. Right, RPG dev. Let's run it. Let's see what we get. We get that. And watch the top left-hand corner, 97. That's interesting. 97. Well, when I move the mouse, it goes down a bit. That's very interesting, because that's exactly the same FPS we had at the start of last stream when we had the model showing on the screen. We'll look at that later. For now, let's debug. Now, how do you start debugging? First of all, go with what you know. We know that the only things that we changed were the resources here. We added the Fong stuff. We also changed in AmberSL how we dealt with that. And it's how we dealt with the Fong color that is going to be the problem, because that's the only thing that we changed. The Fong color GLSL code, I'm not even going to look at it. I'm not even going to look at that, because that is straightforward to me, and I don't normally get that wrong. So what I've done wrong is probably in the API shaders. So this is where the error is. I've already narrowed it down. That's simple enough. We're using the texture shader, so I've narrowed it down even more, so the error is in these two files here. That's the first part of debugging complete. You know where the error is, or the bug. I don't know what it is yet. Is it an error or is it a bug? So let's check this texture shader, shall we? Okay, what have we done wrong here? Okay, we're setting uniform values. That's okay. Binding attributes is... what? Hold on a minute, we just added a shader. Position texture coordinates. Texture shader, vertex shader. Position texture coordinates 0, 1, and 2 is a normal. 2 is a normal. 0, 1, where's 2? Oh, let's change that. Sorry, let's change that. It is bind attrib. Open brackets. That's an error. I forgot to do something. 2, comma. And it has to be the same. Position texture coordinates. Normal. So it has to be the same as that. So I use a copy paste. It's how can you put it? Case sensitive. And also I tend to use plurals when I shouldn't. Like there. That's a semicolon, please. So if I've forgotten it here, what's the betting that I forgot it in the colour shader as well? I did. Let's make sure that that adds up. Position colour normal in the Fong colour vert. Position colour normal. Thank you. Right, checked. Done. Get rid of that. That's not our error. Fong texture vert. We're not looking at that. Right. Let us rebuild. Build. Can I just do rebuild all? That will do it. Where's my coffee? This takes forever. This is why I prefer VS Code. Visual Studio 2019 is a bit slow on the compiles. Oh, we've got a failed. Does not take 8 arguments. What? That's right, it doesn't. This is in main.cpp, and that will be which file? Model converter console main, yes. Model converter console has just been goosed. And I completely forgot about that, didn't I? Because now we need to pass in normals and num normals. We do have normals, don't we, in here? Ah, wait a minute, we need a default case, don't we? If I remember rightly. Yeah, we'll just pop it in. It'll be fine. Just make sure I'm putting it in the right place, shall we? Actually, it's easy to look in the header file. Positions, normals, color, or whatever. Yeah, okay. Positions, normals, color, yeah. Okay, that's done. Rebuild solution. You can tell I didn't do a solution rebuild before, can't you? That'll help. Okay, no errors. Is it going to work? Now that I've actually added the normals to be sent through. There's a good question. Let's have a look. That should fix it. That should fix it. Is this going to be a very short video? No, it's not. Oh dear, even though the code wasn't complete. Yeah. It still doesn't show. Okay, we're going to have to dig deeper. So how the shader works is that we send values to the shader. Okay, so the values when they are sent, get all uniform locations is done automatically. So when the values are sent, they are sent in and they come through this function here, load uniform values. So let's go down to here and we'll have a look at what values it's sending in for model matrix, view matrix and projection matrix. So let's run debug to there. Okay, the program's running. And it's run debug to there. This is not right. It's telling me here that all the locations are -1. Let's just have a look at projection matrix. Let's have a look at light. Light and position. Position -555. That's what we set it to, I think. Color. Well, the colour it's got at the moment is that one, the light colour, 888. Yeah, that's what I normally put for colour. So the light's okay. Model matrix, yeah, that looks fine. It's got all the silly model matrix in there. Projection matrix, yeah, that's okay. Reflectivity 0.5, okay. Sky colour is 0.7, 0.8, 0.75. Yeah, that's fine. View matrix M11, 12, and yeah, that looks fine. -1s, no. So what's happened is our program has not picked up on these locations here. So we can take that off. And we can stop. So our problem isn't in setting the values. Problem is this location here. These are all -1. And if I'm right, that's probably what we set them to as the error value. Yes, it is. -1 is the error value. It's also the return error value from Qt, funnily enough. If it can't find something in the shader, it returns a value of -1. Which is why I recognize that straight off as an error. So this isn't working. Get all uniform locations is not working. So let's come down to, model view projection. We'll stop there. So F1's working, F2's working, F3 is not working. It didn't stop. So that function never gets called. Okay. We've found the error, but it isn't an error. The code's correct. Let's see how that function gets called. Get all function locations. Let's have a look in the header file. Oh, gee, no. No. It's an override. There isn't a function. That tells me that the override isn't working. Which means line 53, virtual void, gets all uniform locations, is not working. Oh, by the way, did anybody else track this down? And if they did, and if you're in chat, did you get it right? Did you find out that get all uniform locations wasn't working? It's a virtual void and it's not working. Why isn't it working? I have no idea. Let's see where we call it from. Here, line 100. It's the last thing we do. We call a virtual function and it doesn't work. Now I know that if I put it before the linker, it's an error. So let's see if we can cause it to error. Cut to make sure that the function actually exists. It looks as though the compiler is removing this function for some reason. This should give an error. Crash. We should now crash. It doesn't get called. That should crash, and it didn't. So that statement is useless. Take it out. It doesn't work. Shaderprogram.h, take it out. It doesn't work. There you go. Done. Doesn't work at all. So our get all uniform locations is not working. Bind attributes is. Okay. And we don't need that either. Maybe we do. So the shader program was drawing a blank on one of our functions. So in texture.h, this is now an error, doesn't exist. Easy, do that. Does now. Just take the override off it. But we need to call it. We have removed its call. So when we create the texture shader, this is now no longer empty. So it's get all uniform locations. Go in there instead. So now we know it's going to get called. It's going to be the same in color shader. .h. We now have an error. Yes. So we do that. Save. Color shader CPP. Empty. And that's going to be get all uniform locations. So we know that it's going to get called. So what should we have seen? Get rid of you. Get rid of you. So now I know it's going to get called. What I'm going to do is I am going to place my marker there instead of there. Alright, so we should come through to here. Now, when the shader is set up, we should come through to that line. Any errors? Yeah, you're working, you're working. We come through to that line, it's this. They're all at -1. Step over. There you go. Model mat lock is now 3. Step over. 8, 4, 2, 1, 6, 5, 7. We've got them. It's the only time that runs, so we can continue. There you go. There's our model. And the shading is working, as you can tell. Wow. That's cute. You can see the light moving around on it. It's an awful lot different to what it was before, isn't it? And now, look at the ears. The ears are the giveaway. Alright? Just look at the ears. How it's drawing them. There's actually faceting going on in the centre of that ear. No, that's right. Wow. That's fantastic because there are light blockings going on there. Would it matter if I turned on the blending properly? Probably do better. I don't know, but that's the result. Let's look at that result and compare it. Let's compare it to the result. Well, from our starting point, shall we say. Our starting point was the last video. So there's me live now. And our last video was this one. Them now say the same thing. And how to do there we go. That's what we had. Get help. No, thank you. Just move you over here slightly. Layout. Pop you up. Dashboard. So you can see the difference now between what we had and what we've got now. So a mass, you can just look at the ears. Okay, I've got a dashboard. The ears were not 3D, but now they are. This is wonderful. That's a massive difference. It now looks more 3D. Now I want to test this not on this model. It's a better model to test this on. Just get rid of that. Alright, so I'll just exit that. What model are we using? We're using body, aren't we? That part's correct now. RPG dev, GLSLs are correct. Everything's correct. It's now our function key. Here we go. Don't need those two anymore. We're loading it up somewhere in here, aren't we? Go. Ah, there it is. Alright, HEAD. This is a model I want to look at. I want to see if something's happening. I don't think it does on textures. I think it would on colour, but not textures. Oh god, still got that thing in. Take that out. Continue. Oh, it is working. Oh good. But now you can see it properly. Let's just back that off a minute. You'll see, look how the shadow comes across. If you do your calculations in the vertex shader, that doesn't happen. And this is a good test of it. So that's a textured object being Phong lit. And you can tell it's being Phong lit by the shadow movement across the face. And the light is probably too close. It's very bright. And we do have a bit of fog effect going on. Well, not much. Okay. That's good. Alright, so I've got this glowy thingy. Just get rid of you. Get rid of you. We're only using... So that's correct. Resources, textures. No, textures are okay. Long texture, vert. I just put two numbers in. So if we increase our fog density, let's say to let's just try on 0.7 first. See what happens. Yeah, that happens. As you can see, it's now whited out. Remember, our background colour is not the correct colour, but that's fog. As you can see, it's just whited out. The background has to be the same colour as the fog, or the fog has to be the same colour as the background. So that's our first problem to solve. Where did we set our background? Fog is not working as expected. So, source, core, function key 3. We set our background when we initialize. I'm sure that we do. Maybe not. Oops. Who sets our background? We have it under platform then in OpenGL. Let's follow it through, let's find our background. Because initially it's set to that clear colour, which is like a dark red. We go through, we do that, then we paint, resize, okay. So we run F3 initialize. F3 initialize. So if has texture, else camera, no background. Okay. Then we hit go. Camera, if texture, else, do nothing at the moment. Okay. That just renders. Is our renderer setting the background color? I think it is. Yep, we've got our renderer setting our background color. That's bad. It should not do that. Yeah. So it's 0.1, 0.2, 0.5, 10. That's where it's doing it. That's our background colour there. We've tracked it down. The only trouble is, down here I've done something completely different. M light, yeah, and I've just put the sky colour in as 7875. That's nothing, it's not even close to being the same. So our sky colour is our background colour. 1251, 125. Okay. Right, let's try it again. And it's a build and run. See, render has now been updated. Good. Right, our fog should now be the same colour as the background. And what a beautiful effect that is. There you go, it disappears. That is actually our cutoff point. So that fog is nearly correct. If we put our cutoff point a little bit further back on our field of view, that will be correct. So we could have a massive field of view, but we'll only see about 50 meters. That's about 50 meters away. That effect is fantastic. The fog is working. Alrighty. There we go, medium distance. So 10 meters or so. That is awesome. Lighting's working and fog's working. That's fixed. Our FOV needs fixing. Our FOV, is that in common? No. It isn't in there, it's in this one. Common. I usually put them in common on purpose so I can find them. Far plane of 50 meters. I'll change that to 75 just to make sure that I'm right. We should lose sight of it about 50 meters or so. I need to do the calculation. I don't think it's 0.7, I think it's 0.5. Right, set it all up. WASD, let's make it go away from us. It should disappear before it hits the far plane. And it does. So everything that appears in the scene will now appear as if it's coming out of the fog. Our far plane is far enough back. That is good, and things that are close up are crystal clear. As you can see, very sharp close up. Take it a few meters away, and the edges start to fade out. Yeah, I like that effect. That effect is good, it's not perfect. How can I make it better? I just changed that number in here. What I'm going to do then is I'm going to make it 0.5 because I think that's correct. It's 1.5 per meter plus 0.5. So 5% every 1.5 meters. I need 20 meters times 2 is 40 meters. Yeah, I think it's 0.5. Yeah, I'll go with that. Because it's a power of, it gets less than it goes up. So power of 0.5 should just about do it at 75 meters. Well, it will do it at 75, but I just want 50 meters view range. Yeah, I'm happy with that. That's Phong texture, Phong color will change as well. Keep them both the same. So density is 0.5 every 1.5 meters increase. Yeah. That should work nicely. Right. That was a nice easy video. Wait a minute, exit a minute. I wanted to look at, so the lighting is working properly, but there is a problem with Mr. Head. Sorry, body. Now we can have a look at it properly now, the lighting effect. I know it's working. And this is something that I'm actually going to not change. This problem is not on purpose, but you can see what's happening. Each of the faces is lighting up and shading down a little fast on the rotation. But it is correct, and it's the model's fault, not the lighting's fault, and that's why I'm not going to change it. The code is correct, it's the model that is wrong. There is something we can change in our code, and that is to use something called smoothed normals. Now, smoothed normals would make our model very efficient, but we would have to smooth the normals at conversion stage, not in our code here. So it would be model converter that we would need to change rather than this code here. We would need to convert the model slightly differently. So I'm not going to change that, but you can see the kind of thing that might happen if you go faceted. It would be large areas just going very light and very dark. We've also got the light behind us, so we've got no specular light. So let's alter our light and check it out. So where do we make our light? We don't. Again, we are messing about in the renderer, aren't we? Because the renderer hasn't been changed yet. So we aren't producing our own light at the moment. We're letting the renderer do it for us, are we? Yep, looks like it. Everything there is correct. I am absolutely 100% satisfied with what we've done so far. Renderer, you're doing the light, are you? Yeah, you are. That's its position. We haven't introduced light fall off. That is correct. We haven't introduced light fall off, so it's just a bright. This is a sunshiny one. There's no light fall off here, and there's no light fall off in our shaders, so I haven't added it in the shaders yet. Would changing the position make it any different? Yeah, I think so. Let's take it to the left by 10. There's no light fall off, so I don't think that's going to matter. 10. And we'll put it on the X line. There's no in, no out. Our model has been pushed back by so many meters. I think it's 3 or 5 meters. I can't remember off the top of my head. Don't really care. So it'll still hit the front of the face slightly. But it should be definitely on the left-hand side now. Top left. Yeah, that's right. That looks better. As you can see, this side is dark and this side is light. And it's shading underneath the head more because the light is top left. The light is actually coming from here, top left, and just coming straight across it in that direction. So that's correct. That gives a beautiful effect, actually. And if we go away from the light is still at the top left and coming down because it's the camera that's moving, not the model. The model has stayed stationary, the sun has stayed stationary, so it's still coming down from here, from about 10 meters to the left and 10 meters up. And that is pushed backwards, so it's still hitting the front of the face. And now the model should just disappear gradually. Beautiful. No clipping. Camera moves forwards. Model comes back into view. Yeah, we've still got a bit squarey, but that's because there aren't enough vertex positions on it. Have we got any glint? Not yet. Okay. I don't know what the roughness settings I've set are, but hey ho, let's try that now. So let's put it into the screen, which is positive. Okay. So the front and bottom should be dark. Yeah, that's correct. We don't seem to be getting that much glint. We might be too low on. How can we make this shiny? Make it a shiny, shiny object. What are we passing in? Float damper we have at 1. Reflectivity we have at 0.5. That doesn't sound right. I don't think it is 0.5. I remember this equation. Two, 4, 8, 16, 32.0. I think it's in values of 2 to the power of 2. We will soon find out if I'm right. Yes, we are. We are right. As you can see, it's now reflecting a lot more light. And if we send that away from us, yeah, it's definitely glinting, starting to glint now. Alright. Let's make it very smooth. I think these two numbers are factors of 2. Or is that one a percentage? Let's find out. I know one of them is a factor of 2. I think we're getting very close to a mirrored type of effect. If we could get to the right angle, which we can't because we've got no up and down. Yeah, that is starting to really glowy glow. So if I'm right, that can go all the way up to 255. 64. I think it's that one. Don't quote me on this, but I think I'm right. Yeah, that's looking very, very shiny. A very, very shiny object. Let's put the sun at no, let's just zero it out straight in front of it by -10. I'll do. Right, that's directly in front of it, so that it's going straight down the camera. The light source is behind the camera. Oh, it's not. I'd sent it the wrong way. Because the camera is in the positive. Okay. That's a reverse. My bad. Right. So, yeah. That is definitely shiny. I don't think we're getting much speculate effect. Let's just try reversing those two numbers. Because one of them is correct. One version is correct, one version isn't. So if we put that to 64. And that to 1.1. It should be just rough and very dull and scattered. Is it? Yes, it is. Very dull and very, well, as you can see by the shadow. The shadow change, can't do the shadow change. Yeah, even the shadow change is better. Yeah. That's taken off all that reflectivity that was messing it up as a model. So that is definitely more of a normal type of surface. Exit there. So we could, let's try putting that up to 0.5 now. Take that roughness to half. Is that the roughness, isn't it? Reflectivity. To there. Yeah, I was right. Yeah, it's just starting to reflect a little bit. Alright, this is looking better. I think I've got them the right way around now. Yeah, we're getting the sparkles. The glints. Yeah, we are definitely getting the glints. There it is, there it is. Yeah, that's the glints. We've got it the right way around now. So, the damper is to a power of 2. So if I remove that down to 2, it should stop the damping. We should get better glints. Surface scatter should now stop and it would become more reflective. Well, more directly reflective. And it is. Let's put it up to 100%. 1.0. That's 100%. Yeah. That is now very reflective and we are getting the glint effect. Just watching the ears on the insides and the outsides here now. Yeah, that looks okay. If I now put this up to 64, what happens? Higher numbers make what happen? Oh, wow. That is glint. That's now metal. Yeah. Yeah, you can see it when you're moving. Look at that. Look at the glints. Yes, we are getting glints. That's that specular calculation. It's wonderful. Oh yes, I'm very, very happy with that. Alright. So I'm going to place that as a power of 2. And we are going to put that as that's a percentage. 1.0f equals 100%. Okay. So you can play around with those. Power of 2, by the way, means binary. 2, 4, 6, 8. No, it's 2, 4, 8, 16, 32, 64. Next one up is 128, but we can go all the way up to 255 and it'll work. I think 255 is the max. If I remember right from a .obj file, I think it is. We can look it up. We've got the obj file to look it up in. I think that's the maximum. Yeah, that is. That's very narrow glints. It'll just sparkle the object. Yeah, we're just getting little diddy sparkles now. That's fantastic. Wow. I'm actually quite impressed. What did we say in the... I'm impressed with that. 5 years of development to get just that effect. And it's fantastic. Let's just have a look in... Here a minute. No, we put it in the frag shade of the notes. Shine damper is the roughness of the surface. And reflectivity is metallicness. Yeah. power of 2. Roughness of surface. In other words, if you get it up to 255, the surface is so rough that you'll get pinpoint reflection. Whereas at 2 or 1, so power of 2, so it goes from 1 to 255. That can be an int. I'm sure it can. It can, yes. But it has to be changed to a float for the calculation. And that is 100%, and that is just how much is reflected. If I was to turn this down to the opposite, you will see that that is the extremes. So you've got hardly anything being, we've got 1% being reflected, and it's being scattered. You should not see any glint whatsoever. You've got a matte surface. Effectively, and that's what you get, a matte surface. There's no glint, you won't get any glints from it at all. And obviously the opposites are like a mirror, a mirrored surface. This kind of matte surface, I think, if you don't get your lighting right, turns into a plastic type of look. So be careful. Be careful how you do these. Be careful with your objects. So the actual correct settings for roughness and reflection should be held in your .obj file. And because we've converted it, our .obj file is in our converter. And it depends whether we convert these values or not. So what have we got here? Whether we take the Blender's figures and use them, or do we put in our own? Do we know enough about what we're doing to use that correctly and to make our own effects? Do we want control over it, or should we just let Blender hopefully do the right thing? I think we should take control over it personally. I don't fancy messing around. No, this is a resources, isn't it? Alright, so we've got the vertex, texture coordinates, normals. We've got the vertex parameters, UVW. Statement can be specified in a line starting with the string variable. So this is for drawing lines, okay. So in other words, instead of drawing a face, you draw lines. So you get an outline, like line, a mesh. It would look like a mesh, kind of thing. Face is face, yes, very complicated and lovely. We took out the quads because we can't use them. Line elements, see below. Record starting a line, yeah, records a line. Yeah, so draws a line on the screen. Other geometry formats. Yeah, okay. So right, we're now into the MTL file. Name, user material, object name, group name. Smooth shading across polygons is enabled by smoothing groups, S1. Don't like to use that. Smooth shading can be disabled as well by using S off, yes. Are we going to see that kind of thing? It's this I'm interested in actually here. This it's Illume 2, I think. So in the MTL file, which I just opened, we get the material name. We get the ambient colour. Note, I've just fixed it. We can read it, and it is there. But you'll find the ambient colour is KA, is it? KA, yes. So KA is just put as 111, which is why I'm not using Blender's version of it. Because unless lighting is specified within Blender when you save it out, and you save out the light source as well, then that will always be a 111. So no, I'm not going to be using Blender's KA. So when we will do our own. No, we've already done our own, so we're going to leave that alone. So I'm happy with that. So that's KA sorted, and I've just got Muppet jumping on me. Sorry about this. Hello, little purr. Hello, you're purring a lot. Yes, you are. Did you get your biscuits or something? Is that why you're purring? Because you got biscuits? Bless him. He looks after me. Without him, I would probably cease to exist very quickly. I'm dreading if I ever lose him. Oh, I think he'll outlive me. I hope, well, hope not really. Strange thought. Right, let's look at KD, which we are using. Wrong mouse. So let's carry on. Let's get that other mouse out of the way. So that's your KA value, your KD value we are using. Obviously, that's your red, green, blue, your RGB. Specular colour. Do we want to use it? We could actually. But it puts it down as 555. Could we use that? Will it always put it as 555? Yeah, it will. No, so we're not going to use it. Okay. Alright, so we're not using theirs. We use our own. Specular highlight component. You see? Here it is. It's a float. As is ours. The specular colour is declared using KS and weighted using specular exponent NS. Range between 0 and 1000. Well, it isn't. It doesn't. That is wrong. That's what it says on the wiki. But it's 2 to 255 for these highlight component, which we call reflectivity, I think. So what component is that? NS. It hasn't given us one. So we would set it to the lowest. We would give it a reflectivity of 0. I've forgotten now. Jeez. Come on, brain. This is a problem having a brain that doesn't remember things. So we give a reflectivity of oh, that's actually 0.1% for that. As well, you can take that down to 6 figures, by the way. These percentages go to 6 figures, if you want to be more accurate. So that's that one there, how much is reflected. We can read it if we want to, but again, in Blender you would have to save out the light source with the model. So we're not going to use theirs, we're going to use our own, it looks like. Emissive coefficient is interesting. Emissive coefficient is how much it shines. Now, we haven't included this in our model, Phong model, because the Phong model is the wrong place to put it. We want a light shader to show lights, or to emit light. And then we need multiple light sources, so that light that is emitted can then be included into our Phong calculation. So you can have pools of light from street lamps and such in the night time. But you would use a separate shader for that. You would not use this texture shader, would not do well for a colour object, and it certainly wouldn't do well for a light or a light bulb or something like that. Refraction index, that was what I wanted to know. Refraction index, the prism effect, how much the light splits up into different colours. The refraction index can be looked up. You can look up the refractive index for water and things like that. You would again not use this in the Phong shader. You would use it in the water shader and the glass shader. And then you would put refraction indexes in for water and glass, and you would hard code those in for those things. You wouldn't take it from here, I don't think. You can, I suppose. A value of 1 will cause no refraction, so I'm guessing that's 0 to 1. Transparency is D or TR. Oh, right, refraction NI, we don't have it. Oh yes, we do. Refraction 1. Yeah, means there's no refraction. Solid object. That means solid object. We could take it from here, we're not going to. D is your transparency. We could take it from here. Again, I think we will. Because we already have it. And we already have done that. It's just I don't think I've included it in the calculations. Which so far hasn't affected us because we've only been doing non-transparent objects. So we have to do that. We have to look at transparency. We have to add that. It's going to change our model converter, and it's going to change the data that we have stored for our models from 3 floats to 4 floats per colour. And it will add the W to the texture, maybe. I'll think about transparency when we come to it. Illumination, this mystical thing that it gives here, illumination 2, it's a table. Highlight on, that's all it means. We could use it and put this table in, but we're not going to. Because what we're going to do is have different shaders for each one. This just tells you which shader to use, actually. When you think about it. It says 2 highlight on. But it doesn't say that it's got a texture. Whereas 0 and 1 tell you the colour on and ambient on or off. So 0 and 1 could tell you which... colour 0 is our basic shader, and illumination 0 is our basic colour shader. Illumination 1 is our Phong colour shader. Illumination 2 is either Phong, texture or colour. We're not doing ray tracing. We would have a separate glass and mirror 1. Reflection, Fresnel, we're not doing Fresnel. Transparency, refraction, reflection, no, we're not doing Fresnel. Ray trace off. Reflection on, ray trace off would be our mirror. Transparency, glass on, reflection, ray trace off would be glasses, our glass one. Cast shadows into invisible surfaces. Awkward. That means casting shadows on glass makes glass visible. If that makes any sense. Or if you have a certain way of doing stealth, you can also use that. Which is how they do it in PlanetSide 2, funnily enough. Stealth in PlanetSide 2 uses Illumination 10. And it's just held as an int. Yeah. Texture maps we have is what we're using, sorry. We are using the diffuse texture map. We haven't bothered with an ambient or a specular because we've got the Phong lighting to do that for us. And specular highlight map, no. Our shader's doing that for us. Alt for texture map, not probably going to use. Bump map, yes, we will introduce. That will make our textures a lot better. Alright. Stencil map, probably not going to use. And well, I'm not using any of this because I'm doing shaders. This you would use if you're not doing shaders. There we go. So yeah, I think we've got everything that we need except transparency included. I'm not sure how that would work on textures. Okay. We've got this far. We've now got lighting effects which are usable. And if you... I'll show you actually what happens. What happens if you turn the light off? Or it's nighttime. Ah, no you can't. It's got to be 0, 0, 1. I think you have to do it to 4 decimal places to get nighttime. Otherwise the calculations probably won't go right. Because we do have an that base light. See how dark it goes. This is an interesting problem, but we have to change our GL clear colour to 4 decimal places as well. So the background colour goes to 4 decimal places. There we go. Hopefully you don't get saturation. There you go. Goes dark. Very dark. Can anybody see the object? I can just because of the ambient light, but I can only just see it. I know there's a shape on the screen that's moving and it's textured, but I can only just barely see it. So again, you have to mess about. Just take a 0 off here. Bring our background colour back up by a factor of 10. Just messing around with variables, seeing where night time is. Or what kind of values I would use as night time anyway. I think I'd probably use these ones. Rebuild the renderer. Yeah. That's more like nighttime. That is very barely visible. Wow. That is very dark still. 1% then. Okay. Go up another factor of 10. This will be too light, most likely. So it's between 0.001 and 0.01, somewhere in here. It's going to be the value. That's probably 0.009 or something. Notice how I have to change them all to make the effect work properly. So this should be a variable. Basically, time of day should set this. And let's see what effect we've made. Yeah, still too dark. Wow. I wasn't expecting that. So I don't know what the darkness effect is how it's going to work. Because there's too many modifications on here. There's too many variables being modified. Oh, yeah. Yeah, I know why now. It's this one here that's going to mess it all up. Background can stay at 0.1, can stay down. It's just the actual volume of light that we're using is probably too low. Yeah, it is. There it is, you can see it now. That's nighttime. So you got your ambient light still illuminating it, but not by much. That is awesome. That is seriously awesome. Yeah, I know how to do the change from night to day now. The change from night to day is 1 or 0.1 times that. Yeah. So the GL clear color becomes 0.1, 0.2, 0.5 times that factor there. So as you move this up, this will change. So then this is controlling, make sure I'm doing the right one actually. Light entity. Oh, I'm doing the color. Yes, that's right. Position color, yeah. So that takes care of your position, that takes care of your color. Sorry, the amount of light in the scene. And this affects the background color or the sky color. So the amount of light times your background will give you the proper background color. That can go all the way up to 1. So if you go to 0.25, you've got dawn. That would probably be 2. So let's have a look at dawn. Can't see it yet. Because I'm not multiplying out, I suppose. Yeah, never mind. Background colour can leave the same. Pull this back up to normal sunshine. Let's see what happens. We might be too dark now, because we haven't changed these back up to what they should be. Again, this can create different effects, just messing around with the lighting. Lighting effects is a big part of the game. Knowing how to mess around with them. As you can see now, the background is still very, very dark. And as you go away, all you'll do is fade out to that darkness. So it'll match itself. Working alright. That's fine. That's working rather well. I'm happy, very happy with that. So, what happens in the final version of this will be, we will have like the sun value, or the main light value. That will be multiplied by the background value to give you your sky colour. And then everything will be drawn on top of that. So this will be changed to sky colour or something. Whatever. Could be interesting. So that controls the amount of light on hitting the object, and that controls the amount of light in the background. There you go. And of course that has to be duplicated down here as the final part of our uniform values as sky colour. I'm going to leave them as hard-coded for now, because I'm not really that bothered about it. Do we want blue as a background? No, I'm not really bothered about that either now. We were only using that colour to test that the renderer was working initially in a video way back. I'll just leave it as it is now. That's fine. I think I've earned a cup of coffee. How long have we been going on this? What's the time? Timer on it? Where's the timers? Can't see a timer there. Can't see a timer there. Oh, 1.5 hours, is that all? Wow. Is there anything else I can do today? Well, yeah, we could start doing this renderer properly. This is not how the renderer is supposed to work. This renderer can only deal with one object. It can only output one object at a time. And it can't do that very well because it has to be textured. Yeah. Yeah, we've only got this draw elements for textured models. We haven't got colour models yet, so it's going to make a bit of a mess if I try and put... I hope this doesn't work. God help me if this works. It should just be a blank screen. Box RGB. I'm going to leave that alone for a minute. I want to do the renderer first, then I want to address transparency once the renderer is working properly. Why does that keep opening? You should close yourself. Yeah, box RGB. It should just give us a blank stare and say, what the heck have you given me? I'm not drawing that. And there you go. Exception thrown, read access violation. That's right, we don't have a texture. So that proves to us that our renderer is not working as we want it to work. It is functioning correctly for textures, but not for the colours. And I think with that, we can save it. Oh, put ourselves back to it. No, that actually looks okay. You can see that the angles, you can see how it's working now on the sides properly. No, I'm happy with that as a demonstration of a single textured object being drawn to the screen properly with a background which is the correct colour. It's slightly red if you can't tell. It's not black. It's just a piece of information for you. Am I going to leave it like that? Yeah, I think so. Have I changed anything out of course by accident? No. But I did put a correction in model converter, which is good. So save everything. And this is now fully functional single texture model to model being rendered with fog, with low fog. That's exactly what it is. And there's your code going up on GitHub. And for anybody who doesn't know how to go to get it, just go to amberskies.org.uk, which should look like that. Is a way to contact me and a GitHub code, which will take you through to github.com Amberskies QT. We're using the master now. So as you can see, it should be here. Is it not here? No, it's not here yet. For some reason it didn't sync. Oh, thank you. Dum 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 dum. Thank you. So just refresh the page. A fully functional single texture model being rendered with low fog. There you go. And there's the code. With everything corrected. Now I haven't gone through full explanations on what I have done this time. They are in the original tutorials. But if you are stuck, understanding any of these numbers that I've just hard coded in, it will become more apparent as I go on. But as I change them into variables, because they do get changed into variables very, very quickly, very, very soon. But also, don't be afraid to ask questions, and don't be afraid to say, I don't understand something, because a lot of people are probably thinking the same as you. I don't understand such and such. Let me know. I'll explain it. I don't mind. I know how all of this works inside out, upside down, and backwards. So this is the kind of code that I do in my sleep. But to other people, anybody who's trying to learn Qt, the fact that, hold on a minute, a virtual function didn't work. Yeah, it's C++. things break. Compiler will break things. It's not perfect. You've got to expect things like that. And we've just hit a compiler bug. That was all. Not a code bug, a compiler bug. Something that the compiler is doing, not us. It was breaking our code, so we fixed it. And we fixed it in a very simple fashion, and now everything works. There you go. We've played around with all the numbers for the fog, we've played around with all the numbers for the lighting, and we've played around with the reflections, and finalised on a matte surface, no reflection type of thing. There we go. But we need control over all of this when we're rendering, and everything's stuffed in the renderer at the moment. So that will be our next stage. Right, what food for thought can I give you? Well, play with the figures, get used to those. Play with those numbers, see what works. Tell me if I'm wrong about the power of 2 thingy. I might be. I might be very wrong. So play with these numbers, and where I said, oh, it's a power of 2, and I've just glibly said it's a power of 2, you know, like roughness, surface 1 to 255. Is that right? Is it? Or is it a value of 1 to 1000? I mean, what happens if I do put that all the way up to 1000? Is that acceptable? Will it just do something strange? Well, it's accepted the number and you can't tell, is the answer. And that's what I found. After 255, I couldn't find any difference. So that gives me the same result as, or should give me the same result as like 300. But it says on the wiki that it's 1 to 1000. I can't see the difference. But if I drop this down to 2, and have a smoother surface, visually, there's hardly any difference because there's no reflection. So even a smooth surface without reflection doesn't do much. Why is it still giving me an... Oh yeah, I have to do it this way, don't I? Because it's special. Okay. So yeah, that number won't do anything until you increase this number of how much is reflected. And if you put this to about 0.5 and then play with that number, you should see different variations happen and different effects. I think 0.5 at 255 is like average. If I put in 0.5 there, I like to put 0.50 because I said it's 100, you know, 1 to 100, so 50%. 50% reflection on a very smooth, rough surface. It shouldn't give much reflection, really. And there you go. You can just about see that light now reflecting. Light's directly behind the camera. There it goes. So it is giving off a reflection. So that now has a semi-shiny surface. But now if I put this to 1000, what happens? It's interesting because I don't know whether they are correct or not. I don't think they are from previous testing. It should basically, yeah, you just get a very, very small light now. I think it's the same as 255 actually. Is that smaller than 255, really? I'll stop doing the whole thing. This is why I use the box to test, so I can see how the area of the reflection is smoother. It says the minimum value is 1, so what happens at 1? It should be maximum half reflection. So as you can see, very, very bright in your face type of light. So yeah, it's the spread of the that's specular. It governs the spread. The higher the figure, the narrower to the glint is the answer. So yeah, it is roughness of the surface. A rough surface has less glint. And if I just put that to about 16, it's a power of 2. You can start seeing the effect more now. Yeah. I mean, so you can see how powerful that center part of the light is now compared to the outside of the light. See how it spreads right out. Gives a general reflection rather than a tiny glint type of reflection. Which is interesting because I think I've got this backwards then. I think it's smoothness, not roughness. Yeah, I think I got it backwards. Nothing happened. Great. Hello, Muppet again. Did you get some food? It's thinking about me changing it. Come on, Microsoft, stop this not responding rubbish. Have we crashed it at long last? No. Power 2, smoothness of surface, I think. Makes me notes wrong. Damn. Oh, come on. What's it doing now? It's throwing a fit. So what I've just said is that the damper is the smoothness of the surface. The higher the damper, the smoother. That's not what I've put in here. R-O-U-G, rough. Yeah. Yeah, that's right. There's more scattering the lower it is. Good. Sounds weird. Rough. Okay. Save all again. So that's my final take on that, I think. But you can see exactly how those numbers were starting to play with the light. Yeah. You've got the code. Right. Corrected. Lovely. I'm rather happy about that. I am very happy about that. That is absolutely amazing. So there's your final code. You've seen me play with the numbers. Hopefully that's giving you a better understanding of those numbers. I use this boxy kind of thing. It's not a box, by the way. It is supposed to... that is smaller. That side is smaller than that side. It's done on purpose. If you see me make a game out there... I used it for the game. The head of the snake game. That looks rather good. I'm sorry. I like that. I like that piece of code now. It's showing the glare as well, properly. That flickering that you can see, I don't know if you can see it. Yes, you will be able to, because you're watching it on YouTube, aren't you? You will be able to see a slight flickering. There it is. That ripple effect. That ripple effect is a natural effect caused by your graphics card. Your graphics card may be different. You may not get it, you may get it, I don't know. I don't know what kind of after effects you're going to get. I like it, so I'm going to keep it. That's what my graphics card does. My graphics card on this machine is rubbish. It's a GT670 or something. It's just a little diddy board with a chip stuck on it. It's not even got a fan. That's how rubbish it is. I used to use it in my server and then decided that, no, my server doesn't really need a TV screen, so why bother? Yeah, I'm done. I hope this allows you to play with the code better, and I hope you have fun with it. So, on that note, I will catch you on Tuesday, and we will get this renderer sorted out, and we'll get all of these variables put in properly. And I want to be able to render color objects as well as textured objects. So that's the objective for next week. Take care until Tuesday afternoon. I stream roughly about 12 till whenever I can, and the cats don't drag me away. 12 noon. I start between 12 noon and 2 PM British summertime at the moment. So take care till then, and enjoy.